Hi everyone, welcome to Atoma 16. On our today's lesson, I'm going to explain how we are going to solve these equations in general. So, in order to find the solution of this one, again, you can look my previous video. I have already solved it similar to this one. So anyway, let me show you how to do this one. First of all, you have to look what is the given information mean. You know, this is the given information. These are given. So how we are going to determine logarithm of 6 to the base 10 is that? So in order to solve this problem, first of all, the answer for this problem is going to be this way. The logarithm of 6 to the base 10 is written as the logarithm of 2 times 3 to the base 10. Now answer for this is that? That means we need to describe 6 as a product of, or we have to describe 6 in terms of 2 and 3. And it is going to be this way. This is exactly logarithm of 2 to the base 10 plus the logarithm of 3 to the base 10. Is that? So what's the logarithm of this one? Obviously x plus 1. What's the logarithm of this? Y minus 1. So this is exactly x plus y will be the solution. Is that? That means the value for log 6 to the base 10 will be x plus y, provided that log x to the base 2 is this one and log 3 to the base is this one. This is the way. Very simple, is that? Simple. Look, let's come to the second problem. When you come to the second problem, the logarithm of 15 to the base 2 mean, this is again given by logarithm of 15 mean 3 times 5 to the base 2. And which is given by the logarithm of 3 to the base 2 times, plus the logarithm of 5 to the base 2. Again, you have to remember the law of logarithm. Is that what the law of logarithm says in general? You know, I have already explained in my previous videos how laws of logarithm will be described. For example, the logarithm of x times y to the base any a is going to be x to the base a plus logarithm of y to the base b. Is that? A. This is written this way. So similarly, log 15 to the base 2 mean log 3.5 to the base 2, which is this one. Is that? And again, this is given by what? What's the log 3 to the base 2? I think this is exactly the logarithm of 3 to the base 10 over logarithm of 2 to the base 10. Is that? Plus, again, what this mean? This is exactly the logarithm of 5 mean, it is written as 10 over 2 to the base 10, to the base 2. It can be written as 10 over 2. So, you know, this is exactly x plus 1 over y minus 1. Is that? Because log 3 mean, this is, I have changed y minus 1 over x plus 1. Is that? Because log 3 mean this one and log 2 mean x plus 1. So in place of this, I have plugged in this one and we can have this. And what's this value in general mean? When you come to the case of this one, how we are going to solve log 10 to the base 2 to the log 10 over 2 to the base 2. This is written as simply the logarithm of 10 to the base 2 plus the logarithm of 2 to the base 2. Obviously, this is the reciprocal 1 over of log to the base 2. This means 1 over of log x to the base 2. Or we can write this as logarithm of 10 to the base 2 is written as log 10 to the base 2 over logarithm of 2 to the base. Sorry. Now log 10 to the base 2 over log to the base 10. That is exactly 1 over what? The logarithm of 2 to the base 10. So which is the reciprocal of this one. So we need to write this mean that's 1 over x plus 1. Is that? And plus log to the base 2 is 1. So what's the sum of all this mean? This is perfectly y minus 1 plus 1 plus x plus 1 over what? X plus 1. And this is perfectly x plus y plus 1 over x plus 1. So this is the solution. This is the final solution of the given problem, because and the same for all these will be x plus 1 divided times divided by 4 these, that is 1 times this, y minus 1 times 1, that's 1, and for these, that's x plus 1 times 1 will be this one, and this is cancelled, but we have left this one, so x plus y plus 1 over x plus 1 will be a value for this one. Is that? Well, now let's come to the second problem. Well, now for the second problem, how we are going to do this problem in the second question. What does this mean, this one? Here, you are asked just to describe the properties of this problem. Is that? The properties of this problem. How are you going to do this one? How we are going to describe the properties of this logarithm in general? Is that? How we are going to? Let's do. Let me just give you 1 minute, okay? Well, I think you already tried, is that? You already tried how to do this problem. Let me just describe the properties of this one. In order to describe the properties of this logarithm, first of all, what this logarithm means in general? Log y, which is gonna be the logarithm of x minus 1 to the base 2 plus 2. How are we going to describe the properties of this one? What property in general mean? Basically, let me explain first of all what are properties of logarithm mean. In the case of exponential and logarithmic function, you have to know what are the basic properties of an exponential and logarithm in general mean. Is that? Because these are very crucial in order to, whenever we have given the function of exponential and logarithm, we need to know the properties or the graph behavior of this exponential and logarithm. There may be a common concept about logarithm and exponential. As you know, every exponential problem is an inverse of logarithm. Is that? An inverse of logarithm. So we have to look this property. If you already understand the properties of exponential, whenever you are given or asked the properties of logarithm, you have to think, you have to look the reverse case of this one. Is that? So let me explain generally how we are going to describe this property. As you know that if this is the graph of x, if this is the xy plane, there is a reference, that's the origin. Is that? Every graph of exponential function will be like this one. If the base of an exponential is greater than 1, the graph will be drawn this way. And you know how to describe the property. If you need, you can just again look back my previous video. If the base of an exponential is in between 0 and 1, its graph will be again like this one. Is that? The graph will be again just like this one. This is the graph of an exponential function whose base is in between 0 and 1. Is that? Here b is greater than 1. Both are exponential functions. This is the first case that you have to remember in the case of exponential. Is that? Then how we are going to describe the properties of this one? What is the domain? What's the range? And the other properties. That's the point. When you come to the case of logarithm, in the case of logarithm, we need just to describe similarly the xy plane. Let's take this is the xy plane. The graph of every logarithmic problem is gonna be graph of a logarithmic problem like this one. This is if the base of the logarithm is greater than 1, the graph of a logarithmic problem will be this one. Look the graph of this one and the graph of this one. Is that? They are mirror image of each other. If you just bring together the graph of the base greater than 1 in the case of logarithm and the graph of an exponential in the case of this is gonna be drawn like this way. Is that? So the graph will be like this one. So these are mirror image of each other along this line. Is that? If this is assumed to be the mirror, now this is the mirror image of this one along this line. Is that? So both are mirror image of each other along the line y is equal to x. So they are mirror image of each other. Means that one is the inverse of the other. Is that? So this is the way how to sketch both the logarithm and an exponential. Is that? So you have to think. Means that if you already understand the properties of an exponential, that's very simple to describe the properties of logarithm. So this is the first point that you have to remember. In the case of logarithm, again, if the base of the logarithm is in between 0 and 1, the graph of this is gonna be like this way. Is that? So this is graph of logarithm where the base is in between 0 and 1. Is that? You have to know. So now let's come to in the case of this problem. What is the base of this logarithm in general mean? How we are going to describe the base of this one? What does this mean, this problem in general? How we are going to sketch the graph of this one? How we are going to sketch the graph of this problem? You have to know this mean, this is always given by the logarithm of x minus 1 to the base 2 plus, we can describe this as logarithm of 4 to the base 2. Since they have this, now this is the reason as logarithm of 4 into x minus 1 to the base 2. We can describe this way. That this problem means this one. So this is the reason immediately the logarithm of 4 into x minus 1 to the base 2. Is that? They're the same. As you know, the logarithm of 4 to the base 2 means 2. So in place of 2, I have just directly plugged another logarithm. So with the of logarithm, when I have just condensed these, now when I am just turn or return to the back, now the logarithm of this will be the product of this energy because they have the same base. Yeah? So that's the principle of logarithm. So we have this one. How we are going to sketch the graph of this one? What is the graph of this problem? This is again given by the logarithm of 4x minus 4 to the base 2. So how we are going to sketch the graph of this one? When you come to the case of this one, what's the domain of this problem? Is that? What is the domain? And what is the base of this logarithm? The base of the logarithm is 2, which is greater than 1. So the graph is always going to be like this way. This is the first point. Before just you come to describe the properties of this problem, first of all, you have to understand the general concept about this logarithm. So here, now look, now again this implies that y is going to be the logarithm of 4x minus 4 to the base 2. Is that? So how could we find, or how could we just describe the y-intercept, x-intercept, and many more? Is that? So first of all, let's find x-intercept of this problem. Always, in order to find the x-intercept of this one, what you're going to make, you have to make this is 0. So to find x-intercept, we need to make y is exactly 0. Is that? So let's just come back to this again. Now this will be the logarithm of 4x minus 4 to the base 2 is going to be 0. Then turn this into exponential, the 4x minus 4, that's gonna be 2 raised 0. Is that? 4x minus 4 will be what? That's perfectly what? This is perfectly 1. And 4x is going to be 4 plus 1, that is 5. X will be 5 over 4. So this implies that x-intercept will be 5 over 4, comma 0. Is that? This is the x-intercept of this problem. This is the way how we are going to determine x-intercept of this one. Again, let's find what's the y-intercept of this one. In order to determine the y-intercept of this one, let me just show you. Make x is equal to 0. To determine y-intercept, make x that is 0. And hence, y is going to be the logarithm of 4 times 0 minus 4 to the base 2. And y is going to be logarithm of negative 4 to the base c, which is not defined. Is that? This is not defined. Because you know that the domain of every logarithmic problem must be greater than 0. That, but in the case of this one, it is negative. Is that? So because of this, this implies that y or f has the function has no x in y-intercept. Is that no y-intercept in general? Because at the very beginning, if you determine the domain of this one, what's the domain of this one? 4x minus 4 is greater than 0. 4x is greater than 0. That I mean 4. And x must be greater than 1. So, in order to find the y-intercept of this problem, x must be 0. But x must be 0 means that in the case of the domain, it is impossible to find the y-intercept, because in order to find the y-intercept, we have to make x 0. Is that? We have to make x 0. But x must be greater than 1. Is that? So because of this principle or law, now we need just to say f has no y-intercept in general. So these are the main point about this logarithm. So now let's see. Let's come back to the other case. So in the case of this problem, what are the basic properties? Is that now basic properties of this problem will be what? Now I'll come back to the basic property, and hence now basic properties of this problem. Basic properties are what? One, has no y-intercept. Is that? Has no y-intercept. And second, x-intercept of this problem is obviously 5 over 4 comma 0. Is that? This is second point. And the domain of this problem is going to be what? What's the domain of this one? Domain is going to be x, say that x is greater than 1. Is that? So this is the domain. And what's the other properties? What's the range of this problem? Range of this problem, range is any real number. Is that? Any real number. X, that means y, say that y is an element of any real number. Is that? Means that it is any real number, means that this problem may be negative, may be positive, may be 0. Is that? Maybe 0. It's maybe 0 again. So that's the point. So any real number will be the range of this problem. And how we are going to describe the other properties? What can we say about the asymptotes of this problem? What's the asymptote for this one? The x-intercept of this problem will be 5 over 4, mean the graph of this problem closest to the vertical line. That is so. Is that? So x is equal to 2. Directly, this added value will be the vertical asymptote. X is equal to 2 is the vertical asymptote. Is that? Now vertical asymptote of the graph. This is the vertical asymptote for the graph. And the last property is going to be what? What's the other properties of this problem? We already did this problem has no y-intercept, x-intercept, domain, range, and vertical. And what's the other property? Since the base of the logarithm is greater than 1, this is an increasing function. Is that? Is an increasing function. Is an increasing function. Increasing functions. Is that? Is sorry. Is an increasing function. Increasing functions. So generally, let me generalize the main point about this one. I think today I have been explained basically many things about logarithm. Is that? And how we are going to solve any logarithm equation, and how we are going to describe the properties of the logarithmic graph. Is that? So always you have to be careful about these 6 properties of every logarithm and every exponential problem. These are very crucial whenever you just ask it about the graph properties of exponential and logarithms. In the case of exponential, for example, this problem is always in existence, means that y-intercept in the case of exponential is always exists. But x-intercept depends, may exist or may not exist. The x-intercept for an exponential is that the domain will be real number and the range is the reverse, that is positive. Is that? Will be reversed. And when you come to this is vertical. In the case of exponential, the asymptote is always horizontal. Is that? In the case of logarithm, this is always vertical. Is that? In the case of exponential, this is always horizontal. And in the case of increasing and decreasing, it is the same for both cases. Because even if every logarithm is an inverse of an exponential, the base of an exponential will be the base of the logarithm. Is that they always have the same basis. If one is the inverse of the other, if the logarithm is an inverse of the exponential, when you find the inverse of the logarithm, when you find the inverse of an exponential, both the functions will have the same base, and because of that, so if the logarithm is increasing, the inverse exponential also increasing. If the logarithm is decreasing, the inverse logarithm, or the inverse exponential will be decreasing. So these are the main points that you have to always remember in the case of exponential and logarithm. Thank you for today. If you are a new member of my YouTube channel, don't forget to share, like, and subscribe at over 16. We'll meet with another lesson. Thank you. Bye-bye.